All right, at this point, we're pros at dealing with normal probability calculations that look like this. I'm exaggerating a bit, obviously. We've had a few examples, but you'll have a chance to practice on this, so we'll get there. So you can handle this one, right? So I'm going to toss a bit of a wrench into the works, and it's kind of solved. So all I've done is put a minus sign on there, and you may have noticed at this point that all of our examples have dealt with cutoff points conveniently living over here. You may have wondered, well, why are we bothering to draw the other half of the curve? I mean, we technically used it once, but you get the idea. So in this instance, we want to know the probability that z is greater than a negative 1.68. So instead of having our cutoff over here, it's living over here somewhere. And we can draw our line up this way, and then we want everything on which side of this. It says z is greater. The point of our inequality symbol points us this way. So we're wanting all of that area that I've just kind of traced out with my fingers. So you might be worried, like, is there a separate body table for dealing with negative z values? I mean, I guess you could make one, but you don't need one. That's kind of the cool bit here, because once again, we're going to fall back on those base properties to help us out. Because what we can do is use the symmetry of our graph and kind of mirror image this thing around. So this area would match up to exactly what we would get if we had gotten rid of this negative sign, but then flipped our inequality around. So our symmetry lets us translate this problem like so. So instead of measuring all this area, I can draw sort of the symmetric cutoff point over on the other side, which I will probably miss because I'm bad at drawing. But so we'll have positive 1.68 over here, and then we want everything less than that because we're going to trace out that area, which is an exact match for what I've kept going over and over and over again, with my hands. All right. So now, going back to the last video, if we want everything up to and including this guy right here, my finger is in the way. There we go. This stuff is 0.5 because it's half the graph, half the total area, and then this part we can look up from our table. So we have the 0.5 running up until we get to 0, or if you wanted to deal with it precisely, the 1/2 area on this side of 0. And then this stuff is the mirror image of something we can look up in our chart, or you can just look that guy up directly, whichever way. So when I looked at that guy, I got 4535. Okay, so now I add these two suckers together, and that gives me 0.9535. So yeah, it is extremely likely we're going to end up grabbing this. As you're saying, grabbing a value that lives in that category. I didn't put a box around any of my answers last video. Oh well. So I described this in the PowerPoint slides. You can even get around having to draw the picture, because if you've got a negative z value, you've got sort of what I call a drop and flip thing going on. We can drop the minus sign, but we have to flip the inequality. So this greater than became a less than, in the transition. So, all right. So let's take a look at another example in action here of this negative thing. So I've got z is less than negative 2.35. So now, I said in my ever burgeoning laziness and hesitancy to try to redraw the picture, so yeah, 2.35 should be like over here somewhere, but you get the idea. So now if we want to be less than negative 2.35, we now want what's on this side of our cutoff line. We want that tail that's over here on this end. We can still use that drop and flip move, though. So get rid of my positive 1.68. I can't erase him cleanly enough. So, yeah, all right. So we would have positive 2.35 over here, and when we mirror image that area, we've got this little tail on this side. And we saw how to find the area of one of those tails previously. We take 0.5, the total from 0 to here, or like I said, equivalently, from 0 back that way, and then we subtract away the stuff that we get out of our table lookup. So if I look up 2.35 in my body table, I saw 4906. And when I do the subtraction there, I get 0.0094. So again, if you have a cutoff point that's a negative number, like I said, the drop and flip, sometimes because I've actually had students before that they end up like writing that down at the top of test papers because they've ended up committing the drop and flip thing to memory for negative numbers. Okay, so now everything that we've kind of built up so far has relied on something kind of useful. We've always sort of been able to call zero into play here. For the base lookups, we were going from 0 to here. For the greater than or less thans, we always sort of ended up relying on 0 being a cutoff and using that part of that area ends up being 0.5. So I wanted to take a look at a couple more examples where that ends up not automatically being something we can handle. So bear with me for a sec while I clean this up. I've got to be very careful not to mess up my picture. All right, so coming back to a new example here. Notice in this instance, we don't have 0 acting as a convenient breakpoint for us. Looking at the picture kind of gives the game away in this instance, but let's just run with it. So if we want to know what's happening between negative 0.43 and positive 0.53, the challenge we run into is the table values, as we say, we kind of immediately don't get to grab at 0. I consider just erasing this line at 0 and then drawing it back in to prove a point, but I think the visual kind of gives you the idea as to what's happening here. Well, 0 up to 0.53, we already know how to handle. This stuff over here, it's from negative 0.43 up to 0, but you could use sort of the drop and flip and work this out using that same kind of mirror image stuff that we've done before. So we can kind of break this thing up. And then to find the total area, we take these two chunks that are conveniently broken apart by 0 and then add them together. So this guy, we can look up directly in the table. When I did that, I got 2019. This one, technically, I need to do one more thing because I need to do the drop and flip deal to move the 0 over here and a positive 0.43 on that side. But it's still something I can look up in the table. And when I look up 0.43 on my body table, I had 0.1664. So now I add these two guys together. So that gives me, if I'm doing my arithmetic right, 0.3683 in that instance. So it turns out anytime you have one of these, you don't have 0 as a cutoff point, but you have opposite signs, you've got a negative term on one side of z and then a positive term on the other side of the inequality, this same move ends up working out. So, for instance, I'll take a look at one more here. So I have negative 1.23 and positive 0.98. Again, technically I should redraw my picture here, but in the interest of time and preserving my image, I'm just going to kind of exploit the fact that the big thing I need is for the two separate numbers to be on opposite sides of 0. So same thing. This I can get from looking up 0.98 in my body table directly. This guy I can get by doing the mirror image thing and looking up positive 1.23 and then adding the results together. So let's see, when I did that, I got 0.3907 for the 1.23, yeah. And when I looked up 0.98, I had 0.3365. All right. So now I can add those two together, and in a weird bit of symmetry, that works out to be 0.7272. Okay, so now I've got two more examples I want to take a look at here. What happens if it turns out both our cutoff points are on the same side of 0? So let me clean this up a bit, and then we'll take a look. Okay, what do we do if 0 isn't acting as a convenient breakpoint? So this time around, we've got 0.92 on the left and 2.10 on the right. So looking at our picture, we're actually after this kind of cordoned off chunk right here. So it may feel like, well, can we find a way to work the zero stuff back in? And again, the picture kind of points us in the right direction. You may notice this area that's right here, that's exactly what we would get if we looked up 0.92 in our body table. And if I look up 2.10, that gives me this whole thing running from 0 out. So that gives me those two guys put together. Well, if I know this, and I know the whole thing, to get this little chunk, I just need to subtract this bit away. So it turns out, if I were writing it out, it looks like this. I work out everything going up to 2.10 minus what happens when I run up to 0.2. So I'm just subtracting this bit out of that whole thing. Okay? So if I look up 2.10 in the body table, I got 0.4821. Again, remember the 0 is that very first column, so I didn't need to look over or anything like that. If I look up 0.92, I got 3212. When I do the arithmetic there, that should give me 0.1609 or 16.09% if I needed to convert to a percentage. Okay, so one more example I want to take a look at here before we drop off this video. But hold on a sec again, got to clean up. So for our final example, it's kind of an, oh no, what happens if we got those same kind of non-zero cutoff points, but both of the values are negative? So we're wanting this area in this case between negative 1.72 and negative 0.16. You may already get the idea that same drop and flip thing can bounce us back into something on this side that's positive. Again, exploiting the symmetry of the graph, we shift this thing back over across the vertical axis. So we have positive 0.16. Do you remember flipping the inequality? I tend to think of changing places rather than worrying about flipping the inequality symbols around. Good gracious. Short on time, don't rush. Okay, so we need to keep z between positive 0.16 and positive 1.72. So the same idea for the last problem works. We can basically subtract this little strip away from what happens if we go all the way out to 1.72. The 1.72 number on my body table gave me 0.4573, I should say, minus when I look up the 0.16, I got 0.0636. Okay, then I do the subtraction, and let's see, that should give me 0.3937, I believe. So there we go. So that's that. So again, I've kind of condensed this. You could almost add this onto that previous 1, 2, 3 list with a 4 and a 5. How to handle what happens if you have non-zero cutoff points and either they're opposite signs like we saw in those first couple of examples, or if they're the same sign like we've seen in these last two. Okay, so we've got one more video on this content I want to take a look at because you might end up sort of having the natural question at this stage of where would a data set like this come up?